NASA just confirmed what SpaceX feared most. Dreamchaser isn't just another spacecraft. It's 4 times bigger than Dragon with 33 cubic meters of pressurized space. Here's what's crazy. Dragon crashes into salt water, damaging experiments. Dreamchaser lands on runways like a normal plane, keeping everything perfect. But why did NASA reject it before? The answer will shock you. They're now desperately trying to fix that mistake as Boeing fails and SpaceX gets too powerful. Could this be the end of Dragon's dominance? Let's dive right in. For years, SpaceX has owned the space cargo game. Dragon capsules launch like clockwork, deliver supplies to the International Space Station, and splash down in the ocean to thunderous applause. But there's a problem. Every single Dragon mission ends the same way. Violent impact with salt water, corrosion eating away at billion-dollar experiments, recovery teams racing against time before the capsule sinks to the bottom of the ocean. Remember what happened to Gus Grissom? His Liberty Bell 7 capsule sank because the hatch opened too early. That nightmare scenario haunts every Dragon recovery operation. Scientists lose months of work. Pharmaceutical companies watch their investments dissolve in salt water. Critical medical research destroyed by the very system meant to protect it. NASA knew this was happening. They saw the damage reports. They watched experiments fail, but they stayed silent because they had no alternative. Until now. Deep in Sierra Nevada's facilities, engineers were building something different. Not just another spacecraft, but a complete revolution in how we think about space logistics. Dreamchaser doesn't look like Dragon. No rounded capsule, no parachutes, no ocean splashdown. Instead, it looks like a miniature space shuttle. Sleek wings, precision control. Built for one purpose, bringing cargo home safely. The numbers are staggering. Dragon offers 9.3 cubic meters of pressurized space. Dreamchaser delivers 33 cubic meters. That's not just bigger, it's 4 times the volume. But here's what makes this truly revolutionary. That extra space isn't wasted. It's specifically designed for the most delicate, most valuable cargo in the world. Protein crystals that could cure cancer. Medical research that saves lives. Scientific equipment worth more than most countries' GDP. And when it's time to come home, Dreamchaser doesn't crash into the ocean. It lands on runways like a commercial airliner. Smooth, controlled, perfect. No salt water, no corrosion, no damage, no delays. Scientists can walk up to the spacecraft within hours and retrieve their experiments in pristine condition. So if Dreamchaser is this superior, why isn't it flying already? January 2014. NASA faced the most important decision in modern spaceflight. 3 companies, 3 different visions, 1 contract that would shape the future of American space exploration. Boeing presented Starliner, traditional capsule design, proven technology, safe bet. SpaceX offered Dragon, innovative but familiar, capsule-based, evolutionary rather than revolutionary. Sierra Nevada proposed Dreamchaser, completely different, winged spacecraft, spaceplane technology, the future, or a dangerous gamble. NASA's evaluation was brutal, every detail scrutinized, every risk analyzed, every possibility examined. Dreamchaser scored well on mission capability. Sierra Nevada had impressive past performance. The technology was brilliant, but NASA said no. The official reasons sounded technical. Schedule risks, system complexity, development challenges, standard bureaucratic language that revealed nothing about the real decision. The unofficial reason? Pure terror. January 28, 1986. Challenger exploded 73 seconds after launch. 7 astronauts died instantly. The nation watched in horror as their heroes disintegrated in the sky. February 1st, 2003. Columbia broke apart during re-entry. 7 more lives lost. Families destroyed. Dreams shattered. Both disasters involved winged spacecraft. Both were spaceplanes. Both left scars that never healed. NASA's leadership carried those memories. When forced to choose between proven capsule technology and innovative spaceplane design, They chose fear over innovation. Sierra Nevada didn't accept defeat quietly. They protested to the Government Accountability Office. They fought with passion and data. They believed their technology could revolutionize space travel. The protest was denied. Dreamchaser was grounded before it ever had a chance to prove itself. But was NASA's fear justified? Capsules are simple. Their rounded, weighted design keeps them stable during re-entry. Even if everything goes wrong, physics takes over. They naturally fall heat shield first. It's elegant in its simplicity. Spaceplanes are complex. They require constant control. Pilots or computers must continuously adjust attitude, speed, trajectory. More systems mean more failure points. One critical malfunction could mean disaster. This is why NASA chose capsules for crew missions. Human lives were too precious to risk on unproven technology. The calculation was clear. Proven safety trumps innovation. But here's what NASA missed. Cargo missions have completely different requirements. Cargo doesn't care about G-forces. Experiments don't need life support. Scientific equipment can tolerate higher risks if the potential rewards are greater. The entire calculation changes when human lives aren't at stake. Dreamchaser's creators understood this distinction. They designed their spacecraft specifically for cargo missions. Maximum pressurized volume, gentle runway landings, perfect preservation of delicate experiments. But NASA's fears had already sealed Dreamchaser's fate, or so everyone thought. SpaceX's dominance seemed unshakable. Dragon missions flew regularly. Cargo reached the station reliably. Elon Musk's company became the poster child for space success. But monopolies create blind spots. NASA began noticing troubling patterns, launch delays becoming more frequent, technical issues causing setbacks, growing dependence on a single provider. What happens if SpaceX faces a major crisis? What happens if Dragon is grounded? What happens if Elon Musk makes a decision that prioritizes Mars over Earth orbit? The Boeing situation made these fears concrete. Starliner was supposed to provide backup crew capability. Instead, it delivered one embarrassing failure after another. Software glitches, thruster problems, delays stretching into years. NASA's backup plan became a cautionary tale about putting all eggs in one basket. Suddenly, diversity looked more appealing than dominance. Having multiple providers meant resilience. It meant options. It meant NASA wasn't hostage to any single company's success or failure. Dreamchaser started looking less like a rejected proposal and more like a strategic necessity. While NASA wrestled with politics and procurement, Sierra Nevada focused on something more fundamental, the science that could change everything. Space research requires perfect conditions. Protein crystallization experiments need stable temperatures and vibration-free environments. Cancer research demands contamination-free samples. Materials science requires precise documentation of every variable. Dragon's ocean landing destroys these conditions. Salt water contamination ruins samples. Impact damage destroys delicate equipment. Recovery delays close critical data windows. By the time scientists access their experiments, the damage is already done. Months of work, millions of dollars, potentially life-saving discoveries, lost forever. Dreamchaser preserves everything. Runway landings mean immediate access, controlled environments throughout the journey, no contamination, no damage, no delays. The pharmaceutical industry took notice. Companies like Merck began planning missions to grow protein crystals in microgravity. These crystals form better in space because gravity doesn't create structural flaws. Better crystals mean better drug design. Better drugs mean cancer treatments that actually work. The economic potential was staggering. Space-manufactured pharmaceuticals could be worth billions, but only if they returned to Earth in perfect condition. Which spacecraft would you trust with a cure for cancer? 2024 arrived with chaos. Boeing's Starliner remained grounded after years of failures. SpaceX faced increasing scrutiny over its monopolistic position. NASA needed alternatives more desperately than ever. Dreamchaser suddenly looked prophetic rather than premature. The spacecraft that was rejected for being too complex now seemed elegantly simple compared to Boeing's endless disasters. Sierra Nevada had spent the intervening years perfecting their design. They addressed NASA's original concerns about schedule and complexity. They proved their technology through rigorous testing. They built partnerships with commercial customers who understood the value of perfect cargo delivery. The spaceplane that NASA rejected was ready to prove them wrong, but technical capability isn't enough. Dreamchaser needed a launch vehicle, and that's where the story gets complicated. ULA's Vulcan rocket was supposed to carry Dreamchaser to orbit, the perfect partnership. American spacecraft on American rockets, national pride and technical excellence combined. But Vulcan faced its own nightmare. Blue Origin's BE-4 engines were chronically late. Supply chain issues caused endless delays. Certification took longer than anyone expected. The irony was devastating. Dreamchaser was ready to fly, but had nowhere to go. The spacecraft that was rejected for schedule risks was now grounded by someone else's schedule problems. May 2025 came and went. The tentative launch window closed. Dreamchaser remained on the ground, waiting for its moment to shine. ULA's CEO, Tory Bruno, made a telling comment. "We waited as long as possible on Dreamchaser because we really wanted to fly them." The enthusiasm was genuine, but enthusiasm doesn't overcome technical realities. While Dreamchaser waits for its launch opportunity, a bigger picture emerges. This isn't just about competing with Dragon. It's about revolutionizing how we think about space logistics. SpaceX's Starship promises massive cargo capacity, but requires specialized ground infrastructure. Those giant mechanical arms called Mechazilla exist at exactly one location. Starship can only land where the infrastructure exists. Dreamchaser can land anywhere. Any suitable runway. Any airport with adequate length. New York, London, Tokyo, wherever the cargo needs to go. This flexibility changes everything. Instead of centralizing operations, Dreamchaser decentralizes them. Instead of bringing cargo to the infrastructure, it brings infrastructure to the cargo. Medical emergencies in space? Dreamchaser could land at the nearest major airport. International collaborations? Scientists worldwide could have direct access to space-returned experiments. Commercial opportunities? Companies could receive their space-manufactured products at their own facilities. The fight isn't really between Dreamchaser and Dragon. It's between two completely different philosophies of space operations. SpaceX's approach: bigger is better, maximize payload, centralize operations, accept trade-offs for efficiency. Sierra Nevada's approach: flexibility is better, optimize for mission success, distribute operations, eliminate trade-offs through innovation. Both approaches have merit. Both serve different needs, but the space industry is expanding rapidly, and there's room for both philosophies. The question isn't whether Dreamchaser will replace Dragon. The question is whether Dreamchaser will create an entirely new market for space services. As Dreamchaser prepares for its delayed debut, the implications extend far beyond NASA contracts. Commercial space stations are coming. Private research facilities will need cargo services. International partnerships will require flexible logistics. Dragon serves the current space economy well, but Dreamchaser might be designed for the future space economy, the one where routine access to space creates entirely new industries. Pharmaceutical companies growing drugs in orbit, materials scientists creating impossible alloys, biotechnology firms developing treatments in microgravity. All of these industries need their products returned to Earth in perfect condition. That's Dreamchaser's true market. Not replacing Dragon, but serving customers Dragon can't serve effectively. The spacecraft NASA rejected for being too risky might be the only spacecraft capable of supporting the trillion-dollar space economy of the future. NASA made their choice in 2014. They chose safety over innovation, fear over progress, the familiar over the revolutionary. But as Dreamchaser prepares for its first flight, that decision looks increasingly questionable. What if NASA's biggest mistake wasn't choosing the wrong spacecraft, but choosing it all? What if the future of space logistics isn't about picking winners and losers, but about embracing multiple solutions for multiple problems? What if Dreamchaser's delayed debut isn't a setback, But the perfect timing for a space industry ready to embrace true innovation? The answers are coming. Dreamchaser will fly. The question is whether NASA will be ready to admit they were wrong. So here's what we know. NASA rejected Dreamchaser in 2014, choosing fear over innovation. SpaceX dominated with Dragon, but salt water destroys billion-dollar experiments. Dreamchaser offers 4 times the space, runway landings, and perfect cargo preservation. The real question isn't whether Dreamchaser will replace Dragon. It's whether NASA's biggest mistake was trusting a single provider in the first place. Because when Dreamchaser finally launches, it won't just be carrying cargo, it'll be carrying NASA's backup plan, SpaceX's competition, and maybe the future of space logistics itself. But there's something bigger happening here, something that goes beyond spacecraft comparisons. The space industry is fracturing into specialized markets: crew transport, cargo delivery, manufacturing, tourism. Each needs different solutions. Maybe the future isn't about one spacecraft ruling them all. Maybe it's about the right tool for the right job. What do you think? Will Dreamchaser prove NASA wrong? Or will SpaceX's head start be too much to overcome? Drop your thoughts below, because this story is just getting started. And if you want to stay ahead of the space revolution, hit that subscribe button, because trust me, you don't want to miss what's coming next.